The speed of light. How does it even work? We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper turtles all the way down.
Yes, it's on the back of an infinite number of hyperrural turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Of course, yes, it's late. Yes, legendary laziness of thumbnails and everything. I was totally gonna do something else, but this was just something that was really easy. So we did that because we haven't done it before. I think you all might find it interesting. So the speed of light in a vacuum, of course. According to physics.nist.gov, the speed of light in the vacuum is approximately, it has been updated, it is exactly, according to the best measurements of the time, 2.99792.458 meters per second. That's pretty freaking fast. It's like 3,000 kilometers per second, approximately. Couldn't just be that 3. Why might it not be that 3? Well, we'll delve into that in just a moment here. But hey, hi Rick, what's going on, my friend? All I know is this has been a fascinating past week. I'm actually starting to get a grasp on what might actually be going on. Do I know what's going on? Not at all. That's why we're going to conjecture, because it's fun. I think the world needs a little bit of positivity. Just the opinion of a dude on the internet. Okay. So what are we talking about? We go to our friend Wolfram Alpha. Of course, links are in the doobly-doo to pretty much everything, except maybe one thing that I forgot to add. We covered it before, I think. But, all right, what is this monstrosity right here? All right. So as we know from our universal binomial factorization equation, what we do is we got our primary action, we multiply it by the boundaries, and we add in our terminal action. 1 plus the geometric action uh, times the break in essentially inverse symmetry or whatever we're going to call it. Basically times 10 to the negative 7. So that basically comes out to be basically a 1 with 7 zeros in front of it there. Because right around 7 zeros, I think that's why they updated the SI units there, just because a lot of these they had error bars, and some of them they're just cutting them off at like 10 digits or so. Just because we have confidence up to this amount. Anytime we can get better or even more data, hopefully it's good data, that helps. Hey, Whitechapel. Hey, thank you for joining. Again, just going to be a little quick thing here, just to take a look at. Again, what the heck is this monstrosity here? Again, at the speed of light, it's one of those guys where primary action is pretty much just its boundaries. I forgot to add in that part. Basically, you have your primary action times the boundaries times the terminal action. And basically, that's the method Chad's been using for the HF8 model. Chaz, it's so late. What are you doing up? It's like 2 o'clock in the morning. I shouldn't even ask that for you, my friend. Good to see you. Good to see you. But, okay. So normally, we just calculate out to the Planck length divided by the Planck time. So that's this right here. I'm going to get into that as well at some point. I learned a lot this past week. I almost broke my computer doing a calculation in a Wolfram notebook, running some video. It's phenomenal. It's phenomenally good. It was totally worth almost killing my computer. I need a new computer. But, okay. So Planck length divided by Planck time. Well, that's 1.6 times 10 to the negative 35 divided by 5.39, yada, yada, times 10 to the negative 34. Okay. Now, according to fast calculations, we add in this. Hey, Titan, thank you for joining, my friend. Yes, yes. We're trying to figure out the stuff and things throughout the cosmos. We'll see what happens. But for our terminal action, because basically that's the primary action. A few of these do have just that. Again, I'll let Thad get into some of the other ones. Totally fantastic. You're gonna love it, I claim. So terminal action is 1 plus, what's this? Wait a second. GGI is the Geesking constant. What the heck is that? All right, we go to our friend Mouth World. Geesking constant is that big, ginormous, crazy thing here, but we're gonna do a little trick. Oh no, that's not the trick I'm looking for. 'Cause we're gonna resume our journey because we're keeping track of our quest here. All right. So we're gonna go to the figure 8 knot from Wikipedia, the mathematical thing. So the figure 8 knot projects a complement. Basically, it's that little twisty kind of like bagel thing that I usually show there. But as we can see, it's a very pretty thing. So it is. We'll cheat. All right. The figure 8 knot is also the hyperbolic knot whose complement has the smallest possible volume. Some may say it's a form of a minimal style of double cover manifold. It's that, yada yada. The Lobachevsky function. From this perspective, a figure 8 knot can be considered the simplest hyperbolic knot. The figure 8 knot's complement is a double cover of the Geesking manifold, which is the smallest volume among non-compact hyperbolic 3 manifolds. Again, some may say it's a minimal manifold, maybe doing some stuff and things. All right, go back to our friend Wolfram Alpha. Thank you, Wikipedia. Right, I don't always donate to places. I feel like that's useful. I feel like Wikipedia has earned a few bucks here and there just for its contributions to humanity. Even just acting as a directory for where you go from there. All I know is on the Wolfram live stream, it's the people that are programming Wolfram Alpha, and they'll occasionally check it just for a quick reference. It's like, oh, the people that run basically Siri and Alexa are occasionally glancing at it. And even Professor Carol's like, go to Wikipedia, just give it a check. Not a bad resource. Okay. So what do we do? All right. Blank length divided by blank time. And we multiply that by 1. So that's part of the binomial factorization equation. That's the square root of the Geesking constant. I literally just typed it in here. That's one of the things I can kind of get away with. We'll do that notation. Doesn't do it for everything. It does it for that one. And then we multiply that by, this is J1 minus J2. Those are the first two answers from the hyperbolic vortex equation. It's right here, as we can see. Answer 1, J1 minus J2. And then we multiply it by that times 10. So the negative 7, kind of a hinge point in our realm of persistence, I'm going to claim. Or at least to the best of my knowledge. What's that come out with, too? Oh, 2.99792458097812. What's the code data? All right. 299, and again, we would put this times 10 to the negative 8. They just have it as the full. Let's do 10 to the 8 meters per second. They basically just have it on the full meters because that's, I guess, what they do. 299, 299, 792, 792, 458, 458, 0, 978. Yeah, again, geometric derivation, so you can get as many digits as you want there. That's also a prediction for some other things as we get better measurements and everything. And this is why experimentalists are key. Do we need a larger collider? Maybe some better detectors? What I'm hearing was that Dr. James Beecham, he's like, at least before we upgrade, I'm not sure the exact thing for the upgrade right now. They were only taking 1/40,000th of the data. They're like throwing the rest of it away. I'm like, Might there be something useful in that data before we spend tens of billions of dollars more on a ginormous collider? We mostly did this one to confirm the Higgs, because that was part of the standard model. I'm just saying we could probably, I don't know, maybe feed a lot of people, invest in a lot of things, maybe rebuild places that are getting destroyed across, I don't know, across our nation, across the entire Earth. We should focus a little bit more on Earth, because if we want to become a spacefaring folk, I don't think a lot of potential folks that we might come into contact with really care about. Are you from the U.S.? Are you from the U.K.? Are you from the? We're going to be Earthlings. Just saying. We're people of the Earth. I think that's pretty neat. But that's all I got for right now. Thank you all for watching. Peace out, everybody. Be safe and crazy world out there. Do our best to make it the best playthrough we can. Shout out to Mr. Campbell. Be safe, everyone.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.
Peace out.